Question 17. The diagram below shows the parabolas y equals 5x minus x squared, that's the upside down one, and y equals x squared minus 3x, that's the upright one. And they intersect at the origin and at point A, which has coordinates 4, 4. So find the area of the region between the parabolas. Now, when I get a question like this, I straight away shade it just because I'm quite a visual learner. It allows me to see what I'm doing. Now, remember that when you're finding an area enclosed by two other functions, you don't have to worry about areas being below the x-axis and therefore having a negative definite integral. That's taken care of by the fact that you find the integral of the upper curve minus the lower curve. So it's really important in the first step to identify two things. The first thing is work out what your bounds are. So we need to go from 0 up to the x value of A, which is 4, because we've got a shaded area that goes all the way up to an x value of 4, so we need to include everything up to there. Then we need to get our functions the right way around. So this is an area you could potentially mess up. You need to have the upper function, the 5x minus x squared, minus the lower function. And another area you could potentially mess up is forgetting to put the lower function in brackets. It's got two parts, so this would be a good way to make a classic sign error if you didn't have the brackets. Then we can tidy up, and I wouldn't recommend integrating with 4 terms. When you can tidy up and get it down to 2 terms, it's going to make your integration much quicker and easier. So we've got 5x minus negative 3x, that gives us 8x, and we've got minus x squared gives us minus 2x squared. Now at this point you could actually factorize this, and you could bring a 2 out the front of your whole integral. I haven't bothered to do it because I think it's not going to make it too much different either way. So I've just gone ahead and integrated these two terms as they are. So integrating your x squared, remember your method is to add 1 to the power, that makes it a 2, and divide by the new power. So if you want to do that over in the margin, it kind of saves you writing out a whole extra line, because now I can see that 8 divided by 2 is just 4, and I can put 4x squared in there. With this one, we raise the power by 1, that gives us a 3, divide by the new power, and we can write it out exactly like that. Next step, we need to sub in our 4 for x, so I've gone ahead and done that. Now you'll notice on this line, I haven't worked anything out, I've just done the clear subbing in. And this is kind of important because if I've got my integral a little bit wrong and I've made a mistake here, there'll be a mark for the subbing in and calculating section. This thing's worth 3 marks. 1 for working out what the bounds are and which order these functions need to go. 1 for tidying up and actually integrating it. And the last mark will be for subbing in and calculating. So by being really clear here about what I've actually done, if I made a mistake there, it'll be nice and easy for a teacher to spot that I have done correct subbing and calculating with this. And the answer comes out as 64 thirds, but since it's area, it might be nicer to write it as 21 1/3 units squared. Notice how I've got units there in my answer.